What's up, everybody? Welcome to episode 1 of the Scratch Platformer series. Through this series, I'm going to be showing you guys how to make a platformer game on Scratch. So let's get started. So since this is episode 1, we're going to focus mainly on just some basic physics to get the game started off. So start off by making 2 sprites. You can call one player and the other one grounds. In the player sprite, just make a rectangle and make sure it's centered on the grid. Next up, for grounds, just take this little rectangle tool and make a bunch of rectangles. Later on, this is going to be our level, but for now we're just going to use it to test our physics. So make sure you have some walls the character can run into and a slope it can try and walk up to, because what we're trying to accomplish is we want our character to stop when they hit a wall. We want them to be able to jump, move left and right, and want them to be able to walk up slopes before we can start on the rest of the platformer game. So for now, just create something like this. It doesn't really matter what it looks like. We're going to delete it later. Also, make sure that on the ground one, you're telling it to go to 0, 0 so that it can be centered. Now let's get started on the code. So I'm going to make a forever loop, and all of our physics is going to be going inside of that. So let's make 2 my blocks, call one of them y physics. This is going to be all the physics along the y axis inside of this, like for example jumping and gravity. Then we can make another one and call it x axis, and this will be the same but for things like moving left and right, walking up slopes. So I'm going to start off with the y-axis. I'm going to do the code for that. I'll finish it up and then I'll explain it to you guys. Alright, so this is all the code we're going to need for right now for the x-axis, except for this little bit right here, which I left empty. We're going to worry about that later. So let me just start explaining it to you. It looks a little complicated, but really it's not that much. So let's start with just this part. Let's ignore this giant if statement right here. I created a variable called x velocity. Just go like that and you can hit OK. And so basically, whenever the right arrow key is pressed, you're going to change x velocity positively. It's going to be changed by 1, so it's going to be changed positively. Whenever the left arrow key is pressed, it's going to be changed negatively. And then you're always going to be changing x by whatever that x velocity is. So if we try it right now, we can see just by pressing the arrow keys I can move. Now this block is also very important, because if I take this block off, this block right here is going to apply the friction. So you can see without it, I'm not pressing the arrow key right now, but I'm still moving. Now, as you can see right there, I just walked through the wall, and this big code right here is basically, this is how it's gonna look. This code is making it so that you can't hit the wall and you can walk up slopes. So let me start explaining that. The first thing we're gonna do is worry about walking up slopes. So we're going to create another variable called old y position. Basically what this script is going to do is you're going to run into something. That's what this thing does. It recognizes that you're touching the ground, so you ran into something. You either ran into 1, a slope, or 2, a wall. So if it's a slope, it's going to want to move you upwards, change your y positively, until you can continue walking up the slope. If it's a wall, it wants to not let you pass. So first off, we're going to assume it's a slope, but it might not have been a slope. So we have this variable called old y, and we're going to set old y to the y position before we do anything. So say we're standing right here. before we assume that we're walking up a slope, because if we tried to treat it like it was a slope, it might not have been. We might have actually been hitting this wall right here. And if that is the case, we can use this old y variable. Say we try and move us upwards, then we move like this. We'd be out of place, but using this old y variable, we can just move ourselves back if we're wrong. If we're right that it was a slope, we're just going to repeat the absolute value of x velocity times. You can ignore the 1, just to imagine the absolute value of x velocity. So that will be, if x velocity is -5, it'll be +5, because you can't repeat something a negative number of times. This absolute value is just going to make it, if it's a negative number or positive number, it'll just turn into the positive form of that. Then we're going to repeat. If we're still touching the ground, we'll just keep changing y by 1. And if that was successful, this script won't ever run, because if that script was successful, we got up like this, we won't be touching the ground anymore. Say we're standing here and it tries to move us up, we're still touching the ground, we haven't solved our problem, so that's when this script will come. If it comes to this, that means we've hit a wall. So it's going to set us back to that variable, bring us back to here, and now we can do the treatment for if we've hit a wall. So we're going to repeat the ceiling of the absolute value of x velocity. So again, absolute value will make it positive. Ceiling is just going to round it up. If we're touching the grounds, again, if we're touching this wall right here, change x by the opposite. Okay, so this is a little complicated. Basically, let's start with this part right here. Any number divided by itself is always going to be 1. So what we're trying to do right here is get, if we were moving in the negative direction, we want to get a +1. If we're moving in the positive direction, we want to get a +1. So this will take whatever we got. If we were moving in the positive direction, the scripts here will give us a +1. If we were moving in the negative direction, it would give us a -1. And then multiplying it by -1 will just reverse whatever it is. So we'll get a 1 that's positive or negative, and it will be the opposite of the way. So because otherwise, if we were here, we're moving in the positive direction like this, and it gives us a +1 to try and kick us out, it would just kick us further into the wall. We need it to know if I'm going this way and hitting a wall, I need to move in the negative direction. If I'm hitting a wall in the negative direction, I need to move in the positive direction. This part, this is where the wall jumps is going to be, so I'll describe that a little later, and this is the friction. So that is pretty much everything for the positive direction. For the x-axis. So let's do the y-axis now. Alright, so this is what the y-axis is going to look like. And again, pretty complicated if statement, but really the important part is that we're forever going to be changing y by y velocity. And if we are not touching the grounds, you can split it into these two things. This will happen if we are touching the grounds, and that's dealing with us not falling through the floor. But if we're in the air, then we need to be lowering the y velocity to make us come back down to the ground. So in here, remember this is only for touching the grounds. We're going to repeat the absolute value of y velocity. I explained that earlier. Check again if we're touching the grounds, and change y. This is, if you remember, this is very similar to, where is it? Over here? No, over here. It's getting a 1 that will be negative or positive. So for the same thing, that x script could detect if we're moving this way, it needed to kick us out this way, and if we're moving this way, it needed to kick it out this way. This is the same. If we're moving positively upwards and we hit a wall, it's going to need to kick us down negatively. And if we're moving negatively to the floor and we hit a wall, it's going to need to kick us back out like that. So next up is jumping. So we only want to be able to jump when we're touching the ground. That's why it's inside of this if touching the ground script. Otherwise we could double jump, triple jump in the air. It wouldn't really make sense. So that's why that's inside of here. However, we only want to be able to jump while y velocity is positive. Sorry, while y velocity is negative. And that's for the simple reason that, so you can actually test this if you make this on your own. Here, my level isn't actually perfect for showing this, but if I draw in a new rectangle like right there, then let me take this code out. So if we didn't care if the y velocity was negative or not, then you can see everything's working great. But if I were to jump up and hit that, I could cling to the ceiling. So maybe if you're making some type of anti-gravity in your game and you want that, that would be cool. But otherwise, we need to make sure that we're only able to jump while the y velocity is negative. Because remember, while the y velocity is positive, that means we'll be moving upwards. If we're just touching the ground, the y velocity won't be negative. And lastly, the gravity, which is just going to keep us down. I already explained that. So there we go. That's basically a lot of the physics that we're going to need. So it's not quite done yet. So I'm going to make one more video. I'll call it episode 2 of the same series, and we're going to finish up the physics in that video. So see you then.